Good evening and welcome to our last session in Specialist Mathematics Student-Centered webinar presented by Texas Instruments Australia. My name is Bozenna. I teach at Wesley College and I will be presenter for our Kinematics session tonight. The following concepts are covered on the course by Specialist Mathematics. We talk about distance versus displacement and velocity versus speed. We look at velocity time graphs and how those can be used to answer various distance questions. We look at motion under gravity and also motion in a resisting medium. And we look at other forms of acceleration. So the whole question was about the projectile, which was fired vertically up from the ground. We know initial velocity was 15 meters per second, and this is the acceleration. So assuming that x is vertically up, x2 dot is another notation for acceleration, x1 dot. In kinematics, we use for velocity, but we can also say v in t, a in t, and x in t. So we'll start our question today with this problem. Still continue with the projectile, and we assume that the motion is just in the vertical direction, and we'll try to answer a few questions and see how the calculator can help us to find the maximum velocity when it occurs, when the projectile reaches its maximum height, the height after 3 seconds, the direction the projectile is traveling after 8 seconds, and displacement and distance after 8 seconds. So let's switch to the calculator. And what we'll do, we'll try to solve this equation using the solve. So as you remember, we were using defaults in our other sessions. I will start with this box, even though this box is only available in CX2. So if you don't have it, you will need to type the solve and type the equations. So I will say that acceleration, so I need x with 2 dashes, and we'll need to type the given formula, which if you downloaded the handout, you could have it in front of you, and plus, and in this entry I can't use quite the fraction entry, so I need to go 36 over t plus 1, and all that is squared. So this is the equation. X acceleration is minus 9 plus 36 over t plus 1 squared. Our independent variable is t, and the dependent variable is x. So we treat x as the vertical direction up in this particular question. What are the initial conditions? We know the velocity, dot, use this bracket here, in 0, and that is equal to 15. And the other condition is the projectile is fired vertically up from the ground. So x in 0 equals 0. Again, as I'm saying, if you don't have this box, you just type your dsolve space and 2 conditions, comma t, comma x. So if I enter, now this is my x, which is the vertical displacement as the function of t. So if I go up and bring it down, now I might tell the computer that x in t, remember that x in t is given by this equation. If I now want to find the velocity, I can differentiate the expressions for x in t, which we already defined on the calculator. and the calculator gives us the velocity. So if you think what's happening with the projectile, when is the maximum height? The maximum height occurs when the velocity is equal to 0. This is our velocity, so we can do a similar trick and say V in t is given by this equation. So now we wish to solve when velocity is equal to 0. So we can use menu algebra solve, and we say V in t equals 0 and comma t. Ignore -1/3. We know it cannot be, t is greater than 0. So we know velocity is 0. So the projectile stops, and that's at the maximum height. So we can find the maximum height as h in 5, x in height. Sorry, that was x, not h. So let's try again. And the question was asking to the nearest meter, which is 78 meters. So the answer to our poll question was D, 78 meters. Once we have x in t and v in t defined, we can actually see how the graphs look like. So we might try to sketch the velocity and velocity and height graph, but I will maybe start with doing our displacement and distance. So the other questions were asking for direction of the projectile after 8 seconds. So we need to remember that direction is given by the velocity vector. So if I find velocity in 8 seconds, it gives me -25, which means that the projectile is on its way down, as we know, because it stops after 5 seconds, reaches maximum height and goes down. So the projectile is on its way down after 8 seconds, given by negative direction of velocity. To find the displacement after 8 seconds, all we need to do is to use a definite integral from 0 to 8, and the displacement is definite integral of v in t with respect to time, and we can obtain an exact value, or alternatively, depending what the exam question is asking, to a particular accuracy, decimal accuracy. If we wish to find distance, we need to use definite integral from 0 to 8, but this time we'll be using absolute value of v in t, because as we know, velocity changes direction, and with respect to t, and if I enter, I get 115.9. So clearly, in the same time, displacement is not equal to the distance, because the object goes up and down. So we need to use absolute value. The velocity direction changes from 0 to 8. But for displacement, it is between the original position and the position where we are after 8 seconds, which is already on the way down. So these are the important concepts: distance, displacement, and direction of motion given by velocity. Sometimes the motion, vertical motion, can be just under gravity, which the gravitational acceleration is always downward, and it's 9.8 meters per second squared, and that this value is always given on your exam. So let's try one question for motion at a constant acceleration under gravity, but we won't be using constant acceleration formula. Instead, we'll just try to do it from first principles meaning that we'll solve our differential equation as we did previously. So what we are given here, a diver jumps from a springboard originally at the height 12 meters above water, and the original velocity is 4.9 meters upwards. And we wish to find the diver's height as a function of time, velocity as the function of time, similarly maximum height, time to reach the water, and the displacement after 1.5 seconds and the distance. So let's try to do it on a calculator. I will insert a new problem. And at calculator, this time I will call it H going up. And if I go to calculus again and use differential equation solver, so I will have H, and I put one dash and another dash. So that's the acceleration in the vertical direction. And it is equal to negative. If we say H up is positive, it's equal minus 9.8. What I will do instead, I will say it's minus 98 on 10 to force the calculator to give me exact values as answers. Otherwise, if I put minus 9.8, the calculator will return decimal values. So independent variable is time, dependent variable is height, and original velocity, h dashed in 0, is equal, and similarly, instead of 4.9, I will say 49 over 10. And original height, so h in 0, was equal to 12. So if I press enter, as you can see now, my h in t is given in fractional form, which, as I say, has this advantage that our answer will actually be, I'm trying to put it as h in t, so h in t, and use the same trick, as sine is equal to this. And again, similarly as we did previously, to find velocity, I will differentiate our h in t function, and that's velocity at any time. So if I want to find the time after which the maximum height is reached, again, we solve this equation, v in t equals 0, t. I didn't do v in t, I did h, sorry. Try again. Okay, so that's my v in t, which I did not assign, didn't tell the calculator that it is my v in t. So we go, this is v in t. And now if I solve, we get t equals a half. So as you see, we are getting decimal answers. And even better, if I now find h in a half, it gives me the exact value. And remember, exact values are required in the exam unless specified otherwise. So that is our trick here, to use fractions instead of decimals to force the calculator to give us exact values. If we want now to find the time after which we get into water, so we go menu, algebra, solve, and we have h in t equals 0, t. And again, ignore this answer, it is 15 on 7. And that is again exact value. We can now sketch h in x. So this is our displacement, which will start from 0 and go to about 20. So we can see the displacement as the function of time. And of course, we could get a 0 here, which is our 15 on 7, but the graph screen will only give us a decimal value. And we can, in a similar way, find the distance and displacement after 1.5 minutes. So if I go 0, and again, instead of 1.5, I will go 3 on 2 to get the exact values. So for displacement, it is definite integral. And if I similarly wish to find the distance as the exact value, I need to enter 3.2, and I need to put modulus of v in t dt. And again, of course, distance and displacement will be different because, as we see, that is actually not from this graph, from VT graph. If we draw V in T graph, we'll see that it cuts at V in X, and that will be our graph here. Maybe not that far. And if we go menu, analyze, graph 0, so that's our half. So if we go to 1.5 minutes, part of velocity changes direction, so distance is not equal to displacement in this particular question. Our next part will be looking at questions when we have retardation, so it's not just motion under gravity, but we might have a resistance. And remember, we need to remember that it is always opposing the motion. So if we look at a few cases, if the motion is down, a resistance is always in the opposite direction, and resistance to motion is proportional to the velocity. It can be just k times v or k times v squared. So our acceleration in this case is g minus kv to the power of n. An object will reach a terminal velocity if long enough in motion. If the motion is up, resistance is down, then we'll have negative g minus kv to the power n, and what will happen? The object will eventually stop. If it is horizontal direction, of course, there is no g having an effect in the horizontal direction, so our acceleration is minus kv to n, and of course, if it's long enough, it will stop depending on the initial velocity. So let's have a look at the first question. A body falls from rest in a medium with an acceleration g minus 0.2 v, where v is the measure of velocity at any time t seconds. So find an expression for its velocity at any time and find the terminal velocity. That means velocity when k approaches infinity, and find the distance fallen in the first 5 seconds. We'll go back to the calculator, and I will get a new problem. Using dissolve again, this time I will type. So I know that v dash, that's acceleration, v dash is equal to, and I will put a fraction here, 5g, so we can use symbols, minus v over 5. I put that on one line because that's easier to enter. And we know that originally v in 0 equals 0, and time is the independent variable, velocity is the dependent variable. So the calculator gives us a nice equation which is in terms of g. And again, we might say, remember that v in t is given by this equation. Now, if we wish to find the terminal velocity, then we'll be using the limit. So if we go to the template, and that's a limit here, and that's when t approaches, where do we get infinity? From the template here, and we put v in t, and that's our terminal velocity just in terms of g. So the calculator will do questions solving differential equations in terms of g and gives us the terminal velocity. Of course, if we want to see how the graph looks like, we need to tell the calculator what value take for g. So let's say we want g to be equal 9.8. And when that's done, we can try to sketch v in x. And of course, we'll need to change the window. And let's make that 100. And that's a nice graph showing velocity as the function of time here. And clearly, if we put 5g on there, 5g, we get our horizontal asymptote. In this question, velocity is always positive, so distance is equal to the displacement. So one other question, the distance fallen in the first 5 seconds, we can again use the definite integral from 0 to 5. We don't need to worry about putting the absolute value. The reason is that velocity does not change direction here, and we get the answer, which we can then round off to the required number of decimal figures. If you do it without defining g, the calculator will return 25g over e as the exact answer. Of course, this question could have been solved also by hand, if that's exam 1, requires a fair bit of work to arrive at the equation which calculator gives us pretty quickly. And we found the distance. Other forms of acceleration, they are given on the VCAA formula sheet. And there is a quick guide which form of acceleration to use. If acceleration is given as the function of time, use dv dt or d2x dt squared. If acceleration is given as the function of x, use d half v squared dx. And sometimes also v dv dx, and that depends on the initial conditions. So let's have a look at this question. A particle moves in a straight line and acceleration a is for x, where x is in meters, and it is displacement from the origin. Given that its velocity is -3 meters per second when the displacement, when we are at the origin, x equals 0, find v in terms of x. So the form of acceleration here we'll be using v dv dx. Oh, my count. Okay, go back. Froze momentarily. So let's go insert new problem, and I get the calculator, and I will use the solve again. And using this form of acceleration v dv dx, I put v times v dashed. So I use here v, and I multiply times v dashed. and it was equal to 4x, so we need a space and another space v in 0 was equal to -3. But this time the independent variable is x and the dependent variable is v. And we get the answer v squared is 4x squared plus 9. We have to give v in terms of x, so the question is what's v? It could be plus minus square root 4x squared plus 9. We use minus because when x is 0, we need to have -3. So to decide which sign to use, plus or minus square root, we need to look back at the initial condition. Velocity was negative when x was 0, so when x is 0, v squared is 9 because it was negative. V equals negative square root of 4x squared plus 9. So the form of acceleration v dv dx has the independent variable x and dependent variable v. So it's slightly different entrance, but it works nicely on a calculator as well. Let's have a look at one question when we have the piecewise function. So a particle moves in a straight line and velocity is given by a quadratic function for time between 0 and 3 and linear when t is greater than 3. Part A, find the distance traveled by the particle from its initial position until it comes to rest. Give the answer to 1 decimal place. And part B, find the time taken for the particle to return to its initial position, correct, to 3 decimal places. Whenever we deal with piecewise function for velocity, we need to define velocity as a piecewise function. To do that, I will use menu actions define, and I will say v in t equals, and we go to the template, and here we have the piecewise function. So let's enter 2 plus 3t minus t squared, and that happens when time is between 0 and 3, and tab 8 minus 2t for time being greater than 3. Sorry. So just check 2 plus 3t minus t squared between 0 and 3, 8 minus 2t, and done. If we now graph it as v in x, that's the graph we get. So let's see a better screen. So that's velocity time graph. If I use analyze 0, that tells me that this particle will stop after 4 seconds. The first part was find the distance travel until it comes to rest. We can use integral here. We go type 0, enter, and move to the intersection point and enter. So this distance is equal to 11.5 until it comes to rest. Then it changes the direction and goes back to the original position. So what we have in here, the area under this part, 11.5, has to be equal to the area of this triangle. How to find the time taken for the particle to return to its original position? There are various ways of doing that. I will do the following. I will use definite integral. Actually, we need to go solve first. Sorry, because I'll be looking for the time. So menu algebra solve. And now I will use definite integral. And we go from 0 to particular value of m. And I will use absolute value. of V in T dt, and I explain in a second, and I will make it equal double this other area, which was 23, and I will solve that for m, which gives me the value 7.391 to 3 decimal places. So what I did, I actually said that if I take the absolute value, the total area will be double this area, because this area here has to be equal to this one. So that is just an easy way of trying to obtain an answer here. Nearly finished. A very last question is the question about the parachutist jumps out of plane and he's in a free fall for the first 10 seconds. After this time, the parachute opens and the velocity can be modeled by this function. Find the distance traveled in the first 40 seconds and the time after which the parachutist lands on the ground if he actually jumps from original height of 906 meters. Again, in this question, we would define, so I will get a new problem, calculator, and I will do menu action define V in T equals, and again, we need the piecewise function. So the first 10 seconds, we are in the free fall. That means that it's 9.8 t, and we go 0 to t and to 10, and then we have the formula 98 over square root 1 plus t minus 10 squared, and this is when t is greater than 0. Defining a function like that allows us to find a velocity at any point, and of course that's the exact value and that's the approximate value. And we can also, having this function defined, we can sketch the velocity time graph, which we again need to change the window slightly. And it looks like we need a bit more here, and that's our nice graph. So originally we are in the free fall, and then as we can see, it is our velocity time graph, and now you can similarly use this function to find the distance using definite integral and solve as we did in a different question. So this is all I'm presenting tonight. There is student worksheet for you to practice some more on those concepts. Thank you very much for your attention, and I hope you enjoyed the kinematics session.